Okay, welcome back. So now we're going to be looking at what happens if we have algebraic denominators. So we have polynomials in the denominator position. So here's our first one here. And we have 1 over a plus 1 over a. Now, these denominators here are both the same. And just like with numerical values, when our denominators are the same, we keep the common denominator and we add the two numerators. In that case, 1 plus 1 will be equal to 2 over a. So still following exactly the same rules that we apply to numerical values. In our next one, same idea, and the same principles apply, just have to make sure that we're applying the signs correctly. Okay, because our two denominators are the same, we keep the denominator the same, and then we just perform the operation on the top. 1 minus 2 is going to be negative 1 over x. Okay, this one here, we have our first example where we don't have the same denominator. And that's okay. It just means we defined the lowest common multiple again. And just like what we did with the numerical values, we can do the exact same with the algebraic ones. If we list a, and we listed all the multiples of a, we have 2a, we have 4a, and so on and so on and so forth. So we have lots of multiples of a, 3a, or all of those. And if we list the multiples of 2a, well, we have 2a as well, and then obviously we can increase that and so on. But our lowest common multiple is going to be these two values. And that should be pretty easy to do without doing this up the top. So we can see that if I multiplied this whole first term, this whole first fraction by 2, I would get the same results. I would get something over 2a. And that means that that's going to be the common multiple that we're going to be looking for. So something over 2a plus 1 here stays exactly the same. Now, to get from a to 2a, we have multiplied this by 2. In order to maintain equivalent fractions, we're going to do the same to the top. So 1 times 2 is just 2. Now that we have the same exact denominator, we can add them across. So we keep our denominator, and then we do 2 plus 1, which is 3 over 2a. All right, let's get rid of all of this. Right, next one. So we have 1 over 2x minus 1 over 3x. Again, we're still looking for that lowest common multiple. And in this case, if we think about just the coefficients, we can see that's going to be 6x. So something over 6x minus something over 6x. In order to go from our value here to 6x, we have multiplied it by 2, so we have to do the same thing to the top. And we change this to 1 times 2, which is 2. And in order to do this to our 6x, we multiplied it by 3, so we have to do the 1 times 3, which is just going to be 3. So, in the end, we've got 3 minus 2 over 6x, which is just 1 over 6x. All right, 3 over 4a plus 4 over 3a. Again, the lowest common multiple between these is going to be 12a, informed by the coefficient. Now, oftentimes the only mistake people make with these is that they try and multiply these both together to get a common multiple. And while you can do that, you need to remember that you'll need to be simplifying a lot more at the end. Alright, so 12a plus something over 12a. Let's look at the first one. How have I gone from 4a to 12a? I've multiplied it by 3. 3 times 3 is 9. How have I gone from 3a to 12a? I've multiplied it by 4. 4 times 4 is 16. Now that I have these two values, I can do 9 plus 16 all over 12a, which is equal to 25 all over 12a. Okay, there's no common values here or common factors here that we can cancel, so that's going to be our answer. Alright, last one. So we have 5 over 6x minus 1 over 3x. Right. The lowest common multiple here will just be 6x minus something over 6x. Because the first fraction is already over 6x, we just leave it the same. What we have to do now is figure out what we've done to the 3x, which means we multiplied it by 2 and apply it to the numerator, and we get 1 times 2, which is 2. So we're left with 5 minus 2 all over 6x. And 5 minus 2 is 3, so 3 over 6x. And we do have a common factor here, right? We can rewrite this another way. We can write this as 3 times 1 over 6 times x. And we can view this kind of just as a vertically, just to do with the coefficients of these two values. So we know that they're both being multiplied by a multiple of 3. So let's divide the top and the bottom by 3. 6 divided by 3 is 2, and then 3 divided by 3 is 1. And we're left with 1 times 1 over 2 times x, which is just going to be 1 over 2x. Now, you don't have to do this entire part here. It's just to illustrate how we're getting these cancellation numbers to work and what we're actually achieving. Okay, that's it for this video. Hopefully it's helpful. I will see you in the next one.